Hello everyone, today I will show you some basics of 2D NumPy array. NumPy array is numeric Python array. So at first I will import some libraries. So import NumPy as np. I need this for every NumPy operation. Besides that, I am importing matplotlib library in case I need to plot anything else. So you already probably know how to create a 1D NumPy array, right? So for example, I'm trying to create a 1D NumPy array like np.ones, or I can create np.ends. So I would create an array of 18 elements, okay? So press Ctrl Enter, and now let's see what's inside that array. Okay, so we got numbers from 0 to 17, right? Now you can create a 2D NumPy array from this one-dimensional NumPy array using np.reshape command. Okay, so in order to do that, first you have to give the name of the array, then how you're gonna reshape that, put the numbers here. So there are 18 numbers, right? So 18 positions, so it can be 3 times 6, that means 3 into 6, right? So then press Ctrl Enter, and you see 3 rows and 6 columns. And if you need to do any other arrangement, such as 9 to the 9 rows and 2 columns, you need to arrange them, you can do this. Okay, so whatever like values you put here, make sure it matches the required total number. So 9 times 2, 18, or 3 times 6 equals to 18, something like that. And sometimes you need to do the transpose of this, so you can use like, now I will store that into a new array, np.reshape array. So I'm storing like 6, 3. So this is my original. So you see 6 rows and 3 columns. Now what I need to do is to transpose the elements. For example, you want to do like this row, make one column, this row another column, and this row another column in this way. That means all the row elements should be transferred to the columns, and column elements should be transferred to the row. So you can do R2.T and press Ctrl Enter. In this way you just see 0, 1, 2 now in the column, 0, 1, 2, 3, 4, 5 is now in the column. So, and you can always store that array in a R3 equals to something like that. Okay. You can do the same for a numeric array that data is imported from some CSV file or some image or anything else. You just get that array and then you can do these operations. Okay, because sometimes whenever you read data from a CSV file, all the elements, for example, you have a CSV file like this, 3 columns and 6 rows, and you want to extract all the elements in the second column, right? And then maybe you have to do some operation like rearrange the second column into some different dimension, like you want to make it 2 times 3. Then you can do that. I'll show you how to slice this one, how to extract all the elements in a second row or second column, something like that. I'll show you in a moment. You can use concatenate function in order to add 2 or more than 2 arrays in column wise or in row fashion. And the command you have to use is np.concatenate. Then within the first bracket use array 1 and array 2, then first array and second array. So for example, I have created these 2 arrays, 1D NumPy array, and each of them have 4 elements in it. If you want to concatenate in x-axis, like you have to use np.concatenate concatenate, and within the first bracket use the first array and then second array, then press Ctrl Enter, and now you see that these are the elements from array A and the rest elements are from array B. Okay. Now how you use the concatenate function for 2D NumPy array. Let's create a 2D NumPy array here. Say x equals to np.array, and in order to create 2D NumPy array you have to use third bracket inside the third bracket. Now say first elements are 1 and 2 and then 3 and 4. Now these are the elements. Now let's see what is x looks like. Okay, so I have created a 2 by 2 NumPy array and name is x, and let's create another array y, which is also 2 by 2 np.array. Now in third bracket I just create 8, 9 and then comma within third bracket. So basically the first elements are first row, and then put a comma, and this second, like these are the elements for the second row of that array. Now in order to add, like place the y elements just below the x elements, you have to make sure that dimension, like the columns, number of columns should be same for both of the arrays. So I have here like 10, 11. Okay. Now let's see how the y looks like. Okay. Now this is also 2 by 2. Now in order to use the np.concatenate function, you have to use np.concatenate, and inside the first bracket, like you have to put the two arrays here and then put a comma. After the comma you have to use axis 0 or 1. What will happen if you use axis 0? If you put axis 0, these elements will be added below the x element. So let's see, np.concatenate and then x, y, and then put axis equals to 0. Now press Ctrl Enter. Now you see, so the x was 2 by 2, 2 by 2 array, y was another 2 by 2 array. So 1, 2, 3, 4, the 1, 2 and 3, 4 are for the first array x, and the second array has been added just below. Now we want to have a look at the shape of this array, right? So np.shape, so we would like to name this array like a z array. Okay, so now np.shape z. Now you see a 4 by 2 array has been created. Now if you would like to add for example 1, 2, 3, 4 are right here for the first array, right? Now you have other elements from the array B. Now you would like to add these elements right here. Okay, for example 1, 2 and then 8, 9. That means this row will be added here in a separate column, and then these 10 and 11 will be below that column, below that actually elements. So how we would like to do that? Let's np.concatenate. Okay, I'll just copy this. But we put axis equals to 1, and then we would like to see z. Press Ctrl Enter. Now you see 1, 2, 3, 4. This 1, 2, 3, 4 are from the x, and 8, 9, 10, 11 are from y. Now in this way, according to your need, you can add elements like in column or in rows. But whenever you would like to add them in row wise, for example here, I would like to make a mistake here. Now I'll put like 3 here. So now you'll get a mistake. Why? Because this one is 2 by 2 and this one is 2 by it's a different dimension, right? So I'll add here 5. So this is like 2 rows but 3 columns, and the other one is 2 row by 2 column. So there is a dimension mismatch. You cannot do that. I'll explain clearly right here. So for example, whenever you are adding them in a new row, right, axis equals to 0, make sure that you know that number of columns for the first array is 2. Whenever you will add the other elements from the second array, make sure their number of number of columns should be the same. But it doesn't matter whether the number of rows are different. For example, I would add another row here, like 25, 35. Okay. Now press Ctrl Enter. Now you see this one has 2 columns and this one has also 2 columns. That's why it's possible to concatenate in this way, like in a new row. The same thing is true whenever you would like to add them in a new column, right? So in order to add them in a new column, make sure their number of rows should be same. For example, like if I press 1 here, you will get an error. It cannot be done, right? Now, so whenever we are trying to add the y elements in another column, like immediately after x, it's not going to happen because there is a dimension mismatch, right? Now, in order to add the elements in a new column, you have to make sure that number of rows for each of the arrays should be similar. And now let's create an example. So this one has 3 rows and this one has 2 rows, right? So it cannot be done this way. So in order to do that, you have to have another row elements, for example, like 2, 8. Okay. Now you can do that. Okay. Now you see there is no error. So once again, in order to put if you want to put a 0 here, the elements will be added in new row. But if you want them to add in a new column, put 1. But make sure whenever you add the elements, like put the elements in a new row, their number of columns should be same. But whenever you want to add the elements in a new column, make sure their number of rows should be same. Otherwise, you will get an error. So far we have seen how to use the concatenate function, but besides concatenate function, vstack function can also be used to do similar kind of operation, but only adding the new arrays in the row fashion. Okay, so we will see with an example, like we are creating an array x with a multidimensional, of course, and another array y that is also with multidimension, I mean two dimension. So let's first see the concatenate operation using concatenate function. 2 arrays of x and y have been created, and np.concatenate xy, then axis equals to 0 to add the y array just below the x array, that means in new rows. Now change some value of y and press Ctrl Enter to see the changes here. Now if you would like to add y array in new columns instead of new rows, press x is equal to 1, then press Ctrl Enter, and now see the result. Now vstack can also be used to add y array in the new rows. So to use vstack, np.vstack, and within third bracket you have to use x, y, and that's all, and then press Ctrl Enter to see the result. You see G2, the new array has been created right here. So you can see that vstack and concatenate function can work in a similar way, but to add the elements in new row. Just one last thing to tell to you. You can use this concatenate and vstack function to stack like more than two arrays together. For example, the first one I'm kind of adding x, y, and then x, and then maybe another y, and all of them that way. So you see that, okay, disable this one. Now you see x, y, and xy. So this portion is first x, and then y, and then another x, and then another y. So in this way it's possible to add them. Now let's see in row fashion. Now you see it is also possible to do the same. Now comment out this section and let's try to see whether it works for the vstack. Okay, what I'm trying to do, x, y, and y, and vstacking them together. Okay, now you see these two and next to y, and these two is basically another y. So x, y, and y, they are vstacked together. In this way, like as many as you want, you can do that, but you have to make sure that the number of columns of each of the arrays should be same. This is true for concatenate as well as vstack function whenever you want to add them in the new rows. Now I would like to show some mathematical operation on 2D NumPy array. Now we have these two NumPy array, right? So print x, and then I also have to print y as well. Okay, now what you see that two arrays like x and y having same dimension, right? So what I'd like to do is add all the elements of x and y to get a numeric value. That means sum of all the elements of both of them. So in order to do that, you have to write down like np.sum, and then inside the bracket write down x comma y, and then press enter, and you see the number 118, which is the sum of all the elements of both of the arrays. So if you're interested to add like individual array elements with individual array elements of y, for example 1 will be added with 8 and 2 will be added with 9, then write down simply x plus y and then press Ctrl enter to get the resultant array. Instead of addition, you can do subtraction, multiplication, or division. In order to do the multiplication, you have to use x star y, and then for division, x divided by y. You can also add a particular number to any of those arrays, or you can subtract or multiply with a particular number to any of the arrays. Like if you'd like to multiply like this g array with like 2, then type z times 2, something like that. Or you can do the logarithmic operation, whatever else you want. So here I am doing g minus 2. You see 2 have been subtracted from the g for every element, so it's kind of element wise operation. Okay, now g times 2 will cause like multiplication, then g divided by 2, that means every element will be divided by 2, or whatever operation you would like to do. So let's use a logarithmic function like np.log log of z, and then you see the result. And also you can do like log base 2 or log base 10 in this way, log 10 of z. You can also find out the smallest number or the largest number. So to find out the largest number, use np.max and then the matrix or z. So the 35 is the largest number. Now let's print g as well. You see 35 here is the largest number. In order to get the minimum number, so you can type np.min and within the third bracket use g to get the lowest number. So 1 here is the lowest number of that matrix z. You can also find out the unique numbers from an array. In order to create an array p, like we have used np.random.randint. so which will give us like 30 values randomly ranging from 0 to 10. Okay, now press Ctrl Enter. Now you see this is the array of 30 numbers which are randomly have been created. In order to get the unique numbers, write down np.unique, and then within the first bracket write down the array p, and then press Ctrl Enter. You see the array has been created, which having only numbers ranging from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 5 is missing. Anyway, so in this way you can get the unique numbers from an array. Now we would like to see how to create an array. In order to do that, we would like to create an array. For example, now let's create an array using some commands, well-known commands. We will create a 3 by 6 array. So this is the array A. You can flip the array in vertical direction or horizontal direction. In order to flip in vertical direction, you have to use np.flip, then within the first bracket the name of the array A, comma, then axis equals to 0, and then press Ctrl Enter, and you see the elements have been flipped vertically. In order to do the horizontal flip, you have to use axis equals to 1 and then press Ctrl Enter to see the result. You can flatten the array elements using the name of the array dot flatten and put first bracket and then press Ctrl Enter. You see the XX array was a 3 row 6 column array, and now it has been flattened. You see the number of elements are like 18 elements are there. You can plot an array using plt.plot, and within that first bracket put the name of the array, and then you can see that YY array above has been plotted here, and sometimes it is required to write down plt.show and then first bracket to see the plot. Now we will see how to use the array indexing. In order to do that, I will create an array named A which have like 20 elements. The array is in 4 by 5 dimension, actually 4 rows and 5 columns. So let's do that. So np dot, I will use the reshape command first, and then np dot add. So I will start from 0 and then we'll end at 20, and then I would like to reshape it into 4, 5. Okay, now let's see A. Okay, now you have got your array from 0 to 19, right? So what we would like to do, we would like to do the indexing. Now the first thing, I would like to take all the elements, I'd like to see all the elements in the first row. So in order to do that, you have to use A, and then whatever slicing you'd like to do, you have to do inside that third bracket here. Okay, so you would like to take the first row, so row number starts from 0 and column also starts from 0, and if you'd like to get only the first row and first column, then you have to use 0, 0. Okay, now you got that. So this is the first row and first column. You'd like to get the first row but second column put like 1 here, so you'll get 1. Okay, so in this way. Now what I am interested to get all the elements in the first row. In order to do that, what you have to do, you have to use the colon command. Okay, inside the third bracket. So you would like to get all rows and then like all, okay, you'd like to get the first row, right? So 0, colon. Now then press Ctrl Enter, and you see the first number before the comma indicates the 0 is the row. So the 0 indicates the first row, and I would like to get all the columns, like in the first row 1, 2, 3, 4, 5. So all the columns. So all the columns, to get all the columns, then put like colon here. In the similar way, if you'd like to get all the elements in the third row, so I'd like to get all the elements here. So what you have to do, so 0, 1, 2. So this row indexing is 2, right? So 2 and colon, you get all those elements. So in order to get all the elements in the last one, you can use like -1 as well. -1 indicates the reverse numbering. This one is -1, this row is -2, this row is -3, and this is -4. Let's see whether you get it or not. -4. Okay, you got it, right? So now, if you are interested to get the like particular column elements, just swap these numbers, right? So we would like to get only the last column, right? So we are interested to know all the rows. That's why you have to put colon here. Colon indicates all rows. And you are interested to know the last column. You can use -1 easily to get all the elements in the last column. So 4, 9, 14, and 19. 4, 9, 14, and 19. You got it, right? So if you are interested to know the elements in the this column, so -1, -2, you can use -2 here. This is one way of doing. Other than that, you can use direct indexing, right? So 0, 1, 2, 3, 4. So you can use 4 to get the last column. Okay, in this way. Now, in some cases, you are interested to find out, like, make a subset of array from this array. Now, I'm interested to get the first column, third column, and fifth column. Okay, so let's see how we can do that. To get that, now I'd like to get all the odd columns, right? But I'm interested to get all the rows, so put colon here for rows, right? And for the columns, so you have to put the columns inside the first bracket here. So 0 indicates the first column, and then 2 indicates the third one, and then 4 indicates the last one. So press Ctrl Enter. Now you see 0. Okay, this one is here, and the third column is right here, and the last one is right here. So in a similar fashion, if you are interested to find out like only a particular subset inside that array, you can do that. For example, you can create which like rows you are interested in. Okay, you already have got this array, right? So name it as B array. Okay, so you already got this one. Now from this slicing, you can do another slicing to get only the required rows. So B, you are interested to know that 0, 2, and all the columns. So press Ctrl Enter. Okay, now you see 0 to 4 and 10, 12, 14 are your expected numbers. Okay, 0 to 4, 10, 12, 14. You got your expected sets number. You have got your expected numbers. That's a subset of the original array. So in 2 steps I have done that. So but you cannot do it in 1 step. For example, I cannot put these numbers right here instead of open and press enter. You see a mismatch. Why it is happening? Because you are interested to know all the columns here, right? This means all the rows of the first column, third column, and this fifth column. So this indicates all the row elements. But again, you are saying something contradictory here. So it's better to do it in like 2 different steps. Okay. Now let's see how you can create a 3D NumPy array. So 3D NumPy array means you have like a 2D NumPy array of 3 of them, like stacking one after another, right? That means you have number of rows, number of columns. Apart from that, you have another dimension okay, how many slices of those array elements are there. Now I'd like to create a 3D NumPy array. For example, array like equals to np dot, and so I would like to create a 3 by 3 by 3 array. So I'll start from 0 and then 27. So this is an array, 1D NumPy array having 27 elements. So I'd like to make it 3D. So underscore 3D equals to r dot reshape. We can use np.reshape command or r.reshape command as of 3.3, 3. So now let's see r underscore 3d. Press Ctrl Enter. Now you see this one, and this one. So I'd like to see the shape of this one. So r underscore 3d dot shape. You see that 3 by 3 by 3. And how you would like to get the indexing here, you can apply the same strategy. For example, you are interested to know for the first array here. So actually you see 3 arrays here stacked, right? 1, 2 and 3. So this 3 indicates 1, 2, 3, okay, and this 3 by 3 indicates this individual 3 by 3 elements. So now I am interested to slice only this last array from this 3D array. Okay, in order to do that, use the slicing array underscore 3D, the array we are interested, and then put third bracket here. Inside the third bracket, as I have told, these 3 numbers indicates 1, 2 and 3 arrays are there, and each of them having this 3 by 3 dimension. Now if you are interested to get the last one, so this indexing 0, 0, 1, 2. So last one indicates the index 2. Now I'm trying to get all rows and all columns. Okay, now press Ctrl Enter, and you see these all elements are right here. Okay, but if you would like to get only the second column and third column of this one, how you would like to do that? So this is rows, this is columns, right? So the column should be then 2, 3. Press Ctrl Enter. I'm sorry, it should be 1, 2. Then press Ctrl Enter. Okay. Now this 19, 20, 25. So 19, 20, 25 and 20, 23 and 26. You see this array. Although it's kind of distorted, it's not in this way you can see, but it's you can always reshape that to get your, or transpose it to get the desired shape. So dot t. Okay, now you see, using this transpose command, I have got this one right. 19, 20, 22, 23, 25, 26. So in the similar fashion, you can slice or any of these 3 arrays from this 3-dimensional array.
Let's do some array manipulation. For example, I have created an array here, A. Let's see the array, which is actually 4 rows and 5 columns. What I'd like to do is I'd like to change all the elements or any particular element of this array with something else. In order to do that, for example, I would make all the first row elements to something else. To do that, like I have to select first like only the first row but all columns, right? So now what I'd like to do, put equals to, and then what array you'd like to use there instead of existing array, you have to type it here. For example, I would like to place like 9 8 7 5 4. Okay, now press Ctrl Enter. It's done. Now let's see A. Okay, now if you see A, okay, originally it was from 0 to 4. What I have done, I have replaced that first row with these elements, so 9 8 7 5 4, in this way, right? Now this is your new A. What I'd like to do is I would like to change only the last element of this array to something else. To do that, okay, so you already have your array here, right? So to get the last element, so actually -1, -1. Okay, so -1. Let's see what is that one actually. Okay, you see that it is 19, right? So I would like to replace that one with 50. Okay, now press Ctrl Enter, and now I would like to see the array. Okay, now you see this array is similar to this original array, except the last element I have changed to 50. In this way, if you are interested to change any particular column with something else, you can always do that. For example, for this array, what I'd like to do, all the elements of the first column I'd like to change with 1. Okay, so this is array A. Now I'd like to change all the rows of first column, right? So this is the indexing. So this colon indicates all rows, and 0 indicates the first column. That means 9 5 10 and 15. Now I'd like to replace it with like all ones, right? So 1 1 1. Now press Ctrl Enter. It's done. Now print A. Now you see that, right? Now you see all the elements of the first column actually have been changed with 1. So in this way, whatever else you need, you can do that. Sometimes it is required to add like extra column right here, right at the end. You would like to add extra column. You can always use the concatenate function to do it. For example, this one has now an array A, right? So I would like to make another column at the end which will have all the elements equals to 0. Okay, so let's create an array np.zeros, so 4. Okay, so B is an element with np.zeros, so all the elements will be 0. But you see the dimension of this one is, let's see, dot shape. So the shape is only 4. That means row. This is a row vector, but you would like to do in column vector, right? So you remember like to use the concatenate function if you'd like to add at the end here. So number of rows should be matched with the number of rows of the second one. That means the uh, number of rows of B should be similar to number of A. Okay, now let's try to concatenate. Okay, so np.concatenate and then A comma B, and okay, but you would like to add axis equals to 1. So press Ctrl Enter. Something wrong. Okay, axis 0. Still it's wrong. Why it is happening? Because this is something should be in a column vector, right? So you have to reshape it first. So b dot reshape it. I would like to make it like 4 rows 1 column. Okay, so now print b. Okay, so I have to make it b equals to. Now I can do it. Okay, it's 1. It's added here. If you want to create an array with all the elements like with zeros, you can write np.zeros. How many number of zeros you want, you can put it here. If you would like to get all the elements 1, so you can write down np.ones. Okay, then press Ctrl Enter. Now you see all the elements 1. Okay, so what I'm interested to do here is, for example, you have an array C, right? So I would like to do the array manipulation in such a way that all the elements of the first column will be multiplied by 5. Okay, so I will take C and I will first select all the rows of first column, then equals to what I have to do is I have to again select all the rows of first column but multiply with 5. Okay, let's say multiply with 6, then press Ctrl Enter, and then I'd like to print C. Okay, so now you see all the elements of the first column have been replaced with all 6, right? So now say I would like to add 10 at the end. Okay, so you can do it like, like you can select the last column and then plus 10 to do that. Okay, for example, this is that one. Now instead of this one, I'd like to take all the last column, but plus 10. Press Ctrl Enter, and then this one, press C. Okay, now you see I have done only the operation for the last column. So in this way you can do your desired operation, addition, multiplication, subtraction, or logarithm for any array, like any columns, for any element, or for any row, whatever else you want. I hope you have got the idea.
Now I would like to show you something about an image. Okay, so SciPy has a built-in library from where we can see the image of an animal. So from SciPy, import miscellaneous misc, and then press Ctrl Enter, and then image equal to misc.face. So in this way we can get an image of an animal. Okay, so to see the image, plt.show that image and press Ctrl. Okay, it will be plt.imshow, imshow. Okay, then press Ctrl Enter. Now you see an animal here, so which is a color image. That means it has 3 dimension. Okay, so red channel, green channel, or blue channel, we call it RGB. Okay, RG and B values. So RGB, a color image constitutes of 3 different arrays, like red, green, and blue. That's why we are supposed to see that this cat image have like 3-dimensional array. So to see that, we will just shape img.shape. Now you see this is number of rows, number of columns, but it is 3-dimensional. Okay, this is the shape of this image. So what I'd like to do is I'd like to create an image from some random arrays. Let's create the red channel of the array, like with some random numbers. So r equal to np.random.rand integer. So what I'd like to do is I'll create like all the elements inside that array should be ranging from 0 to 255, but I'll take something about 20,000 data in that red channel. Okay, similarly I'll do for the G channel, I mean green, the same, and for blue channel is all the same. Now I have got RG and B channels. Okay, now I have to concatenate them in order to create an RGB image which have basically 3 dimension, right? So let's try to concatenate using np.concatenate and then R, G, B, and then let's name it with IM. Okay, so IM equals to that one, and then I'd like to see the shape of this. Okay, something wrong. Okay, I have to put another bracket there. Okay, so now press Ctrl Enter. You see the shape of this IM array is basically 60,000. Okay, now in order to get an RGB image, you have to make it like 3-dimensional. Okay, so 60,000, I'll reshape it in a way to get the image, for example, 100 row, 200 columns, and then 3 of them, so 100, 200, 3. Okay, now I have got the shape, like correct shape. I would like to see the image here. So in order to, okay, let's see the shape first. So 100 by 200 by 3. Now in order to see the image, you have to type in plt.imshow and then IM, then press Ctrl Enter. Now you see the RGB image, although it's random in nature because the values I have taken, they are random, but all of them are ranging from 0 to 255. This is the rule of selecting like the elements of different channels. All of them should be within that range of 0 to 255. Okay, now let's see how we can plot a gray image from this one. So in order to do that, you know that R, G and B 3 channels are here. So I'll take part of each of those channels to create a new channel which is only 2D, like I'll take 100 by 200 dimension. So let's first import linear algebra library from NumPy. In order to do that, I have to write from NumPy import lin alg, and then what I am trying to say is I'll take part of each of the R, G and B channel to create a new channel IM gray. To do that, you can use IM at the rate of, say for example, 21% from the R and then 71% from the G and like 0.07 times of the B channel. Okay, now I have got my IM gray. Okay, then let's try to print that IM gray. What do we see here? The shape of it. Okay, now you see that 100 by 200. Okay, that means I have got only one of those 3 channels by some fraction. Okay, now in order to do the printing, you have to type like plt.imshow then IM gray, but you have to mention the CMap equals to gray here. Okay, so then press Ctrl Enter. Now you see that grayscale image have been printed here. In a similar fashion, if you'd like to print the grayscale image of that animal right here, you can see, you can do the similar operation for that image. Okay, so I'll just take IM gray from that image with the same percentage. Then okay, something is wrong. Okay, I have to rerun that column, actually rerun that cell, and then okay, so I have taken the similar fraction of those 3. Now let's print the grayscale image of that animal. In order to do that, plt.imshow and then imgarray, but make sure that CMap should be equals to gray. Other than that, you will not be able to print it in grayscale. Okay, so basically grayscale image all the pixel values ranging from 0 to 1.
And that's all for today. Thank you so much for watching. If you have any questions, please let me know in the comment box. I'll try to answer your questions. If you like my video, please subscribe my channel and press the thumbs up button. That will help me inspired to make more videos like this. Thanks.